Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus questions from the section on integration and areas. In question 12C, we're asked to find the area of a region bounded by two graphs, two curves here. So we've got sin x and cos x. I've drawn a diagram here. We want the area bounded by these curves between 0, x equals 0 and x equals pi on 4. So we're after this region in here. Now the idea is that that shaded region that we wish to calculate is actually this region underneath the cos graph. So the cos graph is on top. So it's actually this region here minus this region bound by the sine graph and the x-axis. So we're really after this orange region minus this green region here. And if we can calculate that, we can calculate the area bounded by the graphs cos x and sin x from 0 to pi on 4 there. Okay, so let's do this. So the area is going to be, well, this orange section is the integral, the definite integral from 0 to pi on 4 of cos of x. And the green region here is the integral, the definite integral from 0 to pi on 4 of sine of x. Notice that the cos of x graph was on the top and the sine of x graph was on the bottom here. Okay, so I'll just color code that. So this is this orange region here and this is the green region here. So the total area that we're after is the difference of these. So we can just calculate this using the fundamental theorem of calculus. If we wish, we could write this as just one integral here because they're both going between the same limits. So we could just say it was the integral of cos x minus sin x dx from 0 to pi on 4. So the fundamental theorem of calculus says we just need to find an antiderivative of this function, substitute our limits and take a difference, and that will give us the area. So an antiderivative of cos is sine. Sine differentiates to cos, so cos anti-differentiates to sine. Sine anti-differentiates to minus cos. So this overall is going to be minus cos, which is plus cos. That makes sense because cos differentiates to minus sine there. So just be a little bit careful about the plus and minuses with those functions. And so now we just need to calculate sine of pi on 4 plus cos of pi on 4 and subtract sine of 0 plus cos of 0 here. So sine of pi on 4 plus and cos of pi on 4, both of those are 1 on root 2. And in fact, that's why we knew that was the point of intersection here, because sine of pi on 4 and cos of pi on 4 both give that same value, 1 on root 2 there. So this is actually 1 on root 2 plus 1 on root 2, or 2 on root 2, minus sine of 0 is 0 and cos of 0 is 1. Right? So remember, sine starts at the origin here, cos starts at 1, cos of 0 is 1. So overall our answer is going to be 2 over root 2, subtract 1, but we can rationalise the denominator there. 2 divided by root 2 is actually the same as the square root of 2. So this is the square root of 2 minus 1, and we're after an area, so that's square units there. So our final answer is that the area bound by those two curves from 0 to pi on 4 is the square root of 2 minus 1 square units altogether.